Good evening, my dear students. Welcome to HashLearn Studios. My name is Dheeraj, and I'm your chemistry teacher for the day. And we are looking at Group 18 elements, which is part of the lecture series JEE and NEET. So, before we proceed with the current class's lecture, let us quickly recap what we had looked in the previous class. In the previous class, we had worried about Group 17 elements, that's halogen and its compounds. So we had looked at various halogen compounds in the group 1 class, and the recurring part of it was looked at the second class of group 17 elements, and after that we had looked at various numerical problems as well. So we have Yogesh joining us as a first student. Welcome to the webinar, Yogesh. Moving ahead, to quickly look at the CPP question that I had picked up from the previous class. We had asked you, a black powder, when heated with concentrated HCl, gives a greenish yellow gas. Full stop. The gas that is produced acts as an oxidizing and as well as a bleaching agent. When it is passed over slaked lime, that is the key word. When it is passed over slaked lime, a white powder is formed, which is a ready source of gas. The black powder and the white powder respectively are. So I've given you the list of reactions. So you start with manganese dioxide, and then you end up with chlorine and water, and the colored material, when it undergoes oxidation, it leads to the formation of colorless matter or colorless material. And slaked lime, that's calcium hydroxide. When it is undergoing reaction with chlorine, you end up forming bleaching powder, that's CaOCl2, along with calcium chloride and water. So we have given you the detailed reaction here. We have Sakshi joining us as well. So welcome to the webinar, Sakshi. Moving ahead, today is the first class where we would be looking at group 17 elements. Group 17 elements, just like I have told you in group 17, group 18 elements are also quite important, and group 18 elements will not complicate too much with respect to chemical reactions, because only very few elements of group 18 will react, and therefore the number of products that you have to remember would be less. So that way it simplifies your understanding in a very rather drastic way. So we have Peru also joining us. Welcome, Peru. And the next question that you would be seeing, that's the first slide for the day, is the first question for the day as well. So please go through the question. Helium oxygen mixture is used by deep sea divers in preference to nitrogen oxygen mixture because. So we are asking you, if I use nitrogen oxygen mixture, or if I use helium oxygen mixture, what is it that I am going to be benefited with? So that's the question that we've asked you. Helium is much more soluble in blood than nitrogen. Nitrogen is much less soluble in blood than helium. Due to high pressure deep under the sea, nitrogen and oxygen react to give poisonous nitric oxide. That's another option. And nitrogen is highly soluble in water. Which one is it going to be? So Clockmaster says time's up, but you can take your time. Please let us know what is the right answer in this case. Excuse me. So helium is less soluble, nitrogen is less soluble. Due to high pressure, there's a reaction leading to the formation of nitric oxide, or nitrogen is highly soluble in water. Which of it is going to be the answer? Good. So Yogesh says it's 1C. Peru also says it's 1C, and Sakshi says it's 1A. So what is it going to be? Guys, remember, it's a simple yet a very important question. So if you look at the question, it has to be option A. That is, if you take a mixture of helium and oxygen, it has to be helium, oxygen. This can be another probable question. In what ratio, if you ask me, it has to be in 80:20. So if you take a mixture of helium and oxygen, it is used by deep sea divers for artificial respiration. So the next keyword that you have to remember is artificial respiration. So why is it used for artificial respiration? It is used for artificial respiration because of low intermolecular forces. The next keyword is low intermolecular forces. Low intermolecular forces of what? Of helium. Due to low intermolecular forces of helium, it is less soluble. So what happens if it is less soluble? Keep one thing in mind. Due to low intermolecular forces, helium is less soluble. When it is less soluble in aqueous solutions, it does not cause something called as remember this, quite an important term, Kaizen sickness. It does not cause something called as Kaizen sickness. If it does not cause Kaizen sickness is also called as bend in your regular normal term. What are these bends? That is when the gas that is more soluble under very high pressure, when you come to the surface where the pressure is normal, the gas which is more soluble will try to force itself out of blood, leading to the formation of painful muscular movements called as bends. The scientific term for bends is Kaizen sickness. So the right term is, I shouldn't be using too much of that gas which is soluble. Therefore I am using 80% helium and 20% oxygen. Therefore, when worker moves from high pressure to atmospheric pressure, too much of the dissolved gas is not exhaled out. So looking at this, I should be able to tell that helium is much less soluble in blood than nitrogen, because if I take nitrogen which is more soluble, it leads to a condition called as Kaizen sickness, wherein nitrogen is dissolved more, and if it is dissolved more, when it comes to normal condition, that is to the sea level surface, the amount of nitrogen that has been dissolved will be given out, and that given out condition will lead to typical muscular pains called as bends. So good, a couple of you have given me the right answer. So Sakshi gives me the right answer. So let us proceed quickly. So the reason behind the question is this: it has to do something to do with the partial pressure of the individual gases that we are taking, and it is with respect to nitrogen. So quickly look at this question, guys. Clathrates. Clathrates are the compounds obtained from noble gases, and let me quickly tell you, it has to be a multi right option question. So one answer is not right. In this case, a couple of answers are right. So think wisely. Clathrates are compounds obtained from noble gases, and option A water, option B quinol, option C phenol, and option D liquid ammonia. So clathrates are formed by what? So think about it wisely, guys. It is a multi-right option. Yogesh gives us the right answer, but let me tell you, you have more than one right answer in this question. So think about it a little more, guys. Quite an important question. I'll give you what a clathrate is. After that, you'll be able to tell. So clathrate is a chemical substance consisting of a lattice. Let's say it's a chemical substance consisting of a lattice that traps molecules. So if you look at what a clathrate is, clathrate is when a clathrate is formed. The moment it is formed, it tries to traps, or it tries to abounds molecule which gets entrapped into the lattice. So that's exactly what a clathrate is. So go ahead and you should be able to give us the answer. Good. Preeti has joined as a group, says it is option C and B. Let me tell you, good Preeti, it is right, but you have to know that it is A, B as well as C. That is water, quinol as well as phenol. All of these end up giving us the right option. So Sakshi has told it is B and C. Priti also said it is B and C. Yogesh says it is D. Yogesh also said initially it is B, but remember, water, quinol and phenol end up giving us cathalates. But remember one thing in mind, you don't have to remember the reaction for this particular equation. You don't have to remember anything. You just have to remember what clathrates are. Apart from that, you have to remember what kind of molecule will be able to provide us with clathrates. So that is about this question. Good. A couple of you were able to move closer to a question. Moving ahead, the third question for the day. Which of the following is are hydrolyzed by water? Let me tell you, this is also going to be a multi right answer question. So think about it. You'll have more than one right answer in this question. You have XEF2, XeO4, XeF4 as well as XeF6. Which one is going to be the answer? Let me tell you, it is more than one right answer. So go for it, guys. Go for it. Think about it. Which one is going to be hydrolyzed by water? Which one is going to be, or which one are going to be hydrolyzed by water? That's the right way of asking you the question. Clockmaster says time's up. I can give you a couple of more seconds. So Sakshi says it's C and D. Let me start writing the reaction. Meanwhile, others can start working on it. Yogesh says it's D as well as A. I'll start writing the reaction. That should be able to throw you a little more light on these reactions. So if you take XeF2, so XeF2 plus water, that's normal XeF2 plus hydrolysis, should be able to give you Xe plus O2 plus HF. If you are trying to balance the reaction, it will be 2 moles of XeF2 plus 2 moles of H2O, trying to give you 2 moles of Xe plus 4 moles of He, that's HF. So you will have to know that this has something to do with complete hydrolysis. If you look at this is option A. If you look at the second set of reaction, the second set of reaction has something to do with XeF4, XeF4. So if you take XeF4, 6 moles of XeF4 will react with 12 moles of water, trying to give us Xe. Just the variation is going to be in terms of molar coefficients. So XeO3 2 moles plus 24 HF plus 3 O2. This will also lead to complete hydrolysis. Okay, I've spoken about hydrolysis in terms of option A, in terms of option C as of these reactions. Let us quickly talk about the other option, which is option D, that's XeF6. So XeF6 reacts with water to be able to give us XeOF4 plus 2 moles of HF. You have to remember that we are not talking about complete hydrolysis, we are talking about partial hydrolysis. So moving ahead, XeF6 plus H2O gives us XeOF4 plus 2 HF. So if you look at these, option A, C and D ends up giving us the right answer for this question. These are the reason why I've incorporated questions which will have multiple options, because you'll be able to understand a sequence or a concept when it is taught in multiple ways, wherein you'll have more than one right answer in the given question. You will know that there is really more than one answer allowed for questions like these, and option A, C and D are the right answers, wherein they will undergo hydrolysis by water to give us the following products. And I've even told you whether they'll be undergoing complete or partial hydrolysis as given in this case. And XeO4, that's xenon oxide, in a way will not be able to undergo hydrolysis. So we have Preeti who says it's B, C and D. So unfortunately it is not B, guys, it is A, C and D. Most of you ended up giving us the right option, but we will not form the hydrolysis product with water, but others will end up forming hydrolysis product. So this is the question. Moving ahead, which of the following statement is correct for a noble gas? Which of the following statement is correct for noble gas is the question. Until and unless I mention that it is a multiple right question, you'll be able to answer it in a single MCQ. Go for it. It is a single right answer question, guys. Which of the following statement is correct for a noble gas? I don't think you'll be needing that that amount of time, that's 45 seconds, is not going to be needed for this question. The first option is neon is used in electric bulbs. Krypton is obtained during radioactive disintegration. Half-life of radon. Radon is again a noble gas. Half-life of radon is only 3.8 days. Xenon is used in producing very low temperatures. So what is it going to be? So Sakshi ends up giving us as A as an answer. So what is it going to be? So think about it. Which of the following is correct for a noble gas? Neon is used in electric bulbs? No, definitely not. Neon lamps were different. Neon is not now used in electric bulbs. Before the invent of LCDs and LEDs, we had neon playing a major role. Now neon is not used. Krypton is obtained during radioactive disintegration. No, we have different methods of obtaining krypton, which we'll be seeing in a short while. And xenon is used in producing very low temperature. Xenon has no way a role to be playing in temperature. So the option is half-life of radon is only 3.8 days. So I want you guys to know that 4C is the answer. So among the given option, which is the right answer? 4C, half-life of radon is only 3.8 days. Yes guys, if you take X amount of, let's say, X kg of radon, the time period that is needed for X kg of radon to disintegrate itself to half of the initial amount would be around 3.8 days. So that's a really short period of half-life. So radon is one of those elements which has a really short half-life, and it has a half-life of around 3.8 days. So half-life of radon is only 3.8 days is the right answer. So Yogesh, initially it was A, which you guys gave as the right answer. Guys, it is not definitely used in electric bulbs. You should remember that. Neon were initially used in those tube lights and lighting appliances which were after electric bulb, but before electric bulb or during electric bulb, it was definitely not used. So get that clarity right. Moving ahead, a little time for a quick breather. So chlorine cannot displace. So this was the previous classes contest question. So we asked you, chlorine cannot displace. So which of the following atoms or molecules involved in the options will not be able to or will not get replaced by chlorine was the question. So chlorine cannot displace iodine from NaI, bromine from NaBr, fluorine from NaF, and none of these. So we have a person who has answered the right question. It has to be Peru who gave us the right question. So we have Peru joining us in today's episode as well. So Peru gives Y as the answer. That is, chlorine cannot displace fluorine from NaF, whereas as I move down the group, the element which is above in the periodic table will be able to replace the element which is below, but the element which is above will not be able to be replaced by the element which is below. So Peru gives us the right answer. Congratulations, Peru. Peru has won himself an atom session, which gives him exclusive right to get one of the concepts from PCMB or a difficult question to be solved by our in-house experts. The best part, I should be able to tell you, the best part is within 20 seconds of posting the question in the group, you should be able to give the right, we should be able to give you the right answer. So that's a really big deal, Peru. So go ahead. I'm quite sure you'll be able to use the opportunity in a very wise manner. And the next slide that you would be seeing, guys, would be the current classes contest question. So you will have 60 seconds of time, and we have quite a good number of people joining us. Go ahead, try to answer this question. I'd want people to answer this question the fastest, because the one who answers it the fastest will get an atom session. You know what it does. So the next slide is the Time's up, guys. So fastest finger first. We have quite a few giving us the right answer. As you know the drill, the right answer as well as the explanation for the question will be given to you in the next class of mine, which is tomorrow. So we have two consecutive sessions of mine tomorrow. It's going to be a big deal wherein we'll be completing P block and starting with D and F block. So move ahead with the fifth question for the day, which is not true for quantum mechanical liquid. I'm not going to give you any idea about it. I want you to work from your end. So ask as many questions as possible. This question I'm going to allot as homework to you guys. So ask the right question and then we will proceed. So the fifth question for the day that I've packed for you guys is going to serve as homework. Take a couple of more seconds. You should be able to give us the right answer. Go ahead quickly. Think about it. If you're not too sure about the question, ask us questions which will be taken care of in the next class. So Yogesh says, I'm talking about quantum mechanical liquid, that's helium-2. It has very high thermal conductance, low viscosity, flat meniscus and very low surface tension. Its electrical resistance is 0. It is a superconducting liquid, and He2 as much entropy. This is the question. I'll take all your answers. We'll be looking at this question in tomorrow's class as well, because I want to cover a little conceptual data with respect to this particular question, wherein I'll give you a little idea about this question and take it ahead in the next class of mine, which is tomorrow, guys. So moving ahead, I'm quite sure we have Yogesh giving us B as the answer, Preeti and Sakshi gives C as the answer. We'll take it ahead, guys. We'll take it. Tomorrow's class, we'll be able to briefly discuss about quantum mechanical liquid, and from there we will take it a little ahead, because it's always been a tough nut to crack. So people have had problems with quantum mechanical liquid. We'll talk about it and we will take it ahead. So quickly look at this question. Exactly. So Sakshi has asked us a question. We will look at that in depth in tomorrow's class, Sakshi. Remember this question, quite an important question. So formation of O2 plus PT, platinum F6 minus, is the basis for the formation of xenon fluorides. This is because, so if you look at the initial conditions wherein the noble gases were trying to form compounds with its atoms, this was one of the first compounds to be formed, and we are asking you what is so special about this compound which led to the formation of other compounds. So that is the key question. Good. Sakshi gives us the right answer. The right answer is oxygen and xenon have comparable ionization enthalpies. You don't have to break your heads too much. You just have to answer to the point. So answering to the point in 17th group elements will fetch you quite some marks at your All India examination, which are going to be conducted very soon. So oxygen and xenon have comparable ionization energies, and if I have comparable ionization energies, pretty straightforward. If I have comparable ionization energies, the giving and taking electrons, if it is ionic, and sharing of electrons happen at a much faster rate compared to other properties. Therefore the ionization enthalpies matter to us quite a lot. So like I said, Sakshi gives us the right answer. Moving ahead is the seventh question that I've packed for you guys. Move ahead guys, move ahead. In the case of noble gases, the following trend: xenon, krypton, argon, neon and helium, which is in the reverse order. Xenon, krypton, argon, neon and helium is correct for. So which of these property is, that is the trend, is correct for which of these following properties? So have a detailed look at it. Boiling point, solubility in water, ionization enthalpy, and ease of liquefaction. So how easily I can convert it into a liquid. So which of it is it going to hold good for is the question. So should be straightforward. So Yogesh says it's 7C. Fine. Others, Preeti, Sakshi, who have been joining us for quite some time. Go ahead guys, let us know what is going to be the right answer. Peru. So go ahead guys, go ahead quickly. So Yogesh says C, Sakshi says it's D, and Preeti also says it is D. Let me quickly tell you, yes, Preeti and Sakshi is right. It is, as a matter of fact, D, because it refers to ease of liquefaction. If it is supposed to be boiling point and solubility, if you are looking at the first two properties, that's boiling point and solubility, the order will be xenon, helium. As the xenon to helium, I would say you'll have the middle atoms in the given range. So xenon to helium, because as the, this is going to be a key, as the size of atoms decreases, the order is also supposed to decrease. However, you should remember one thing, the ionization enthalpy increases. So if you look at all of these order, boiling point is going to decrease with decrease in atomic size, solubility in water is going to decrease with decrease in atomic size, ease of liquefaction is also going to decrease with decrease in atomic size. The only property which will not decrease with decrease in atomic size is ionization enthalpy. Therefore, excluding ionization enthalpy, everything else is supposed to be following the option D. That is, all of these property decreases with decrease in atomic size. Good. So Preeti and Sakshi gives us the right answer. Moving ahead to the 8th question. Have a look at the 8th question, guys. We are looking at the basicity. So we have moved to a relatively easier question. Predict the relative basicity of the following ions: F minus, Cl minus, Br minus, and I minus. Which of these is going to be the most basic and which of these is going to be the least basic? If you can give us an answer, I'll be really glad. Go for it guys. Shouldn't take us too much time. Least basic and the most basic ion among the halides: F minus, Cl minus, Br minus, and I minus. Which one is it going to be? Clockmaster says time's up. I can give you a couple of more seconds. No problem. Preeti, Sakshi, Yogesh, Peru, go ahead and try to give us the answer, guys. Go ahead. Yogesh says it's B. Preeti, Sakshi says it's C. Go ahead, Preeti and Peru. Let us know the right answer in this case. Let me quickly tell you. Okay, Preeti also says it's option C. Yes, Sakshi, Preeti is right in this case. So we have Supraja joining us. Really warm welcome, Supraja. Welcome to the webinar. And in this case, the right answer is option C, which is F minus greater than Cl minus greater than Br minus and I minus. Let me quickly give you the reason, guys. So as, if you know, as volume increases, or I should be telling you, charge density decreases from left to right. So as I move across the periodic table, charge density should decrease because the volume of the corresponding atoms decrease. So as I move from left to right, charge density decreases, and that's exactly why the basicity of ions should also decreases as I move from left to right, and it is applicable as I move down the group as well. So charge density decreases from F minus to Cl minus to Br minus to I minus. Now what is basicity? You should know. The basic character or basicity has something to do with the liberation of the lone pair of electrons, which will be able to give away the lone pair of electron very easily. A very smaller atom, a larger atom, the smaller atom should be able to give away an electron very easily because its electron density is high. In that case, fluorine will be able to give away an electron easily. On the other hand, after fluorine comes chlorine, after chlorine comes bromine, and after bromine comes iodine. Iodine will not be able to give away the lone pair of electron as quickly as fluorine. Therefore, fluorine being maximum and iodine being minimum, the basicity order should follow option C, which is F minus, Cl minus, Br minus and I minus. Pretty straightforward. So good, Peru also at last gave us the right answer. Let us quickly move ahead with the ninth question, guys. So ninth question, you should be able to sail across the question pretty easily. Have a look at it. The following statements pertain to noble gases. So we are looking at noble gases. So we are asking you which of the statements pertaining to noble gases will matter to us. As in, it's the right statement. Argon is the most abundant noble gas in atmospheric air. Helium is the lightest non-inflammable gas. The valency of noble gases is 0. All noble gases are absorbed by coconut charcoal. So we have asked you 4 questions and the clock master says time's up. So have a detailed look, guys. Have a look. I'll be able to give you a couple of more seconds. Should not be a problem from my end. So have a look at the ninth question. Which of it is going to be right? Most abundant, the lightest non-inflammable gas that's given in the list, that's helium. The valency of noble gases is 0 and all noble gases are absorbed by coconut charcoal. So which one is it going to be? So Yogesh, Preeti gives us the first answer. Good. Preeti says it's 9A. Yogesh also says it's A and Sakshi also says it is option A. Yes, it's definitely right. Argon is the most abundant noble gas in the atmospheric air. We get to know from experimental observation. Helium is the lightest non-inflammable gases. Quite evident. The valency of noble gases is 0 because it has fully filled uh, electronic orbitals, and all noble gases are absorbed by coconut charcoal. No, except helium. Except helium, all other gases are, that's all other noble gases are absorbed by coconut charcoal. So statement number 1, 2, 3 is right, which is option A. Good. So people who have given us the answer as given us the right answer, I'm really happy, guys, for you, Preeti, Yogesh and Sakshi. Moving ahead, the 10th question that is packed for today. Have a look. The xenon compounds that are isostructural with IBr2 minus and BrO3 minus respectively are. So we are asking you which of these structures are same. The moment I say isostructural, we are asking you which of these following structures will match. So there are two structures in the question and you have around 8 structures in the option. Quickly tell us which one is going to match. That's going to be a 10th question. Quickly. So the clock master says time's up. I can give you a couple of more seconds. Yogesh comes up with the right answer. I'm really glad that Yogesh is coming up with answers. Yogesh says it's 10B. Let me quickly check. Let us look at what is the structure for IBr2 minus and BrO3 minus. Guys, IBr2 minus, it should be a cakewalk for us because IBr2 minus is linear. So IBr2 minus is linear, depends on your chemical bonding understanding, and BrO3 minus is supposed to be pyramidal because it has 3 bonds and a lone pair. So BrO3 minus has 3 bonds and a lone pair, and IBr minus has 2 bonds and it has 3 sets of lone pair. So what is it going to be forming? So which one else apart from IBr2 minus and BrO3 minus will be forming linear and pyramidal? So the moment you get that answer, you should be able to really give us the right answer. So which one is it going to be? So Yogesh says it's B. Preeti also says it's B, but pretty much I think I have given you guys the answer, guys. It is XeF2, which is linear in nature, and XeO3. It is pretty straightforward. Quite a few chemical bonding type of molecules and questions come into the picture, because we are worried about VSEPR theory as well as the structure. So you can incorporate all of these questions in questions like these and chapters like these as well. So IBR2 will give you a linear structure, whereas in XEF2 will also give you a linear structure where it has 2 bonds and 3 lone pairs, and XeO3 I'll consider the double bonds as single bonds, so it's going to be forming 3 bonds and you'll be having the rest as the lone pair. So that's pyramidal for you. So linear XeF2 and pyramidal XeO3. So good. Yogesh gives us the right answer. Moving ahead, guys. So I think this is one of the last questions we have packed for you. Which of the following reactions of xenon compounds is not feasible? So we have given you a list of xenon compounds, and we are trying to react that with hydrogen fluoride, water, and RBF. So we are asking you which one of it is not going to be feasible. So the moment you look at it, you should be able to give us an answer, because XeO3 plus 6HF, XeF4 plus 6H2O, XeF2 plus 2H2O, and XeF6 plus RBF. So which of it will not be a feasible? Feasible here stands for possible. So which of it is not going to be a possible reaction is the question, guys. So Preeti has asked us a question. Just give us a little time, Preeti, here. We will get back to that. So we have Yogesh and Shadi giving us the answer here. So both of them say it is D. Preeti also says it's D. We have Mustafa who is joining us right now. He also says it's D. Sakshi also says it's D. Okay, let me quickly give you the right answer. Let me break the suspense for you guys. It has to be option A, because the moment you have XeF6, if XeF6 is formed by XeO3 and HF, the moment you have XeF6 and 3H2O forming, this reaction is perfectly reversible, giving us back the reactant. So XeF6 plus 3 moles of water ends up giving us XeO3 and 6 moles of HF. So the first reaction is a perfectly reversible reaction, wherein I'll not just be able to form the products, because the formed products will undergo reaction in order to give us the reactants back. So option A is the right answer. I'm leaving you guys with two questions for the day. Two questions for the day. The first question is something to do with let me write that for you. Having told you the answer for this, it's a reversible reaction, guys. I'm leaving you two questions, because tomorrow we'll be having two sessions of mine. The first session starts at 7:15 and ends at 8 o'clock, and the consecutive section starts at 8:15 and ends at 9 o'clock. We'll be looking at the electronic configuration and position aspect of noble gases, and some exclusive questions to do with group 18 elements, that noble gases. And we'll be looking at other exclusive stuffs, that's quantum mechanical liquid or quantum mechanical fluid, that most of you have questions with. Apart from that, I'll try to look at VSEPR structures to do with halogens, because having asked you the questions to do with VSEPR structures, a lot of you had hindrances or problems with. So we will look at VSEPR structures to do with halogens, and we will also look at a concept called as quantum mechanical liquid, wherein we have quite a few questions arising. So Mustafa has asked us a question. So Mustafa says, sir, maximum coordination number possible is 7. Not necessarily, Mustafa. Tomorrow when I am looking at VSEPR theory, I will throw in a little more light, wherein I'll tell you what is the minimum coordination number and what is the maximum coordination number possible for the given set of elements and compounds. So please do wait for our class which I would be covering in tomorrow's class. Like I said, 2 classes, guys, and we are going to be extensively looking at all of these things, which will trouble you in all India level examinations. So that's your chemistry teacher for the day. Now let us quickly try to summarize. Group 18 elements, we have looked at some of the basic aspects of group 18 elements. We have a good number of concepts, quite important, I would say around 2 to 3 concepts: VSEPR, quantum mechanical model, and structures to do with pertaining to whatever we have dealt with in today's class, and also numerical aspects of whatever we have covered in today's class. We will definitely cover in tomorrow's class, because we are getting two consecutive classes wherein we will be able to cover a big deal of information as well as questions. So thank you for joining us today, guys. I hope today's class was interesting and enthusiastic. If you have liked our classes, please go ahead and share our video classes among your friends as well and help them. And people who have access to CPP, go ahead. It's your time to answer the question with the heat of the moment. For people who do not have access to CPP, all that you have to do is to subscribe to Passport, and Passport subscription is just a couple of clicks away. The moment you subscribe to Passport, it doesn't just give you access to CPP, it gives you access to 24/7 one-on-one doubt solving sessions. Apart from that, it gives you practice questions and tests from some of the best-selling books, and also access to all the video classes covering the toughest concepts and problems. Please stay tuned. It is your chemistry teacher Dheeraj, always wishing great for you guys. Till tomorrow's class, it is me signing off. Have a great day.